Hey everyone, welcome back. Today we are going to explore something super important in the world of operating systems, the Virtual File System or VFS. If you have ever wondered how your apps can open and read files so easily, no matter what system you are using, VFS is a big reason why. So, let's break it down simply and clearly. VFS stands for Virtual File System. It's like a bridge between the operating system and all the different types of file systems out there. Instead of every application trying to understand every type of a file format like ext4, NTFS, FAT32, VFS gives them a standard way to interact with files. Think of VFS like a translator. It speaks one language to applications and another to the actual file systems, but it keeps things smooth and simple for the user. So, why do we need VFS? It's all about abstraction and standardization. Abstraction means that the details of how files are stored or accessed are hidden from applications. Apps just make basic calls like open this file or save this document, and VFS handles the rest. Standardization means apps don't have to be rewritten for every new file system. Developers just use the standard system calls, and VFS makes sure it all works. Whether the file is on your SSD or a USB stick or a network drive. Let's look at how VFS is built. At the top, we have user space applications. These are your normal programs. When they need to interact with files, they make system calls like open, read, or write. These calls go to the VFS layer inside the operating system kernel. Then, VFS hands things off to the right file system driver, which knows exactly how to handle the specific file system. So, you have got layers, apps, VFS, file system driver, actual file. Now, let's talk about the key data structures inside VFS. First is the inode. This stores metadata about file, like its size, owner, and permissions. Then we have dentiries. These are directory entries that map file names to inodes. They help speed up file path lookups. Finally, there are file objects. These represent files that are currently open by a program. These objects work together to keep everything fast, efficient, and organized. When you use a command like make dir to make a folder or read to open a file, VFS is an action. It takes these standard system calls and turns them into file system specific actions. For example, read inode might be used under the hood by a particular file system driver. This means every file system, whether local or remote, can be handled in a constant way. Okay, there are tons of benefits to using VFS. First, portability. Your apps work on any file system. Modularity. You can plug in a new file systems without breaking everything. Flexibility. Create for supporting USPS, virtual machines, or network drivers. Security. Access control is centralized through VFS. Real-world use? Linux relies heavily on VFS. Network file systems like NFS and SMB use it to access files over the internet. And virtualization software uses it to share files between guest and host machines. Okay, finally, so that's the virtual file system in a nutshell. It hides the complexity of different file systems, keeps your apps portable, and lets your OS stay flexible and secure. If you learned something new today,
give this video a like, and don't forget to subscribe for more tech explainers. Got the questions? Drop them in the comment below. I am always happy to help. Thanks for watching.